function composition, we'll be looking at f of g of x. Here we have a function that is given to us as f of x, it's quadratic, f of x equals x squared, and another quadratic function for g of x, which equals x squared plus 4. And to find f of g, we can look at it as f of g of x, which is another way of writing f of x squared plus 4. So I'm going to use as an input x squared plus 4 in my f of x function. Now I have to go ahead and square this binomial. So f of g of x will equal x to the 4th plus 8x squared plus 16. Now we'll look at g of g. That's g of x, or g of x squared plus 4. X squared plus 4 is now my input, which is going to go in place of my x in the function g. So that's x squared plus 4 squared plus 4. Now I'm going to square my binomial, which is going to equal x squared plus x to the 4th plus 8x squared plus 16 plus 4. Now I can combine my like terms and I get that g of x is equal to x to the 4th plus 8x squared plus 20. Let's look at another example, but this time we'll be evaluating a function composition. F of x is an absolute value function, the absolute value of x. G of x is 1 over x squared plus 1, and we're asked to evaluate f of g of 4. So we'll start by looking at g of 4. We'll substitute 4 in place of x, and we get 1 over 16 plus 1, or 1 over 17. That becomes my input in my f function. So f of 1/17 is equal to the absolute value of 1/17, which equals 1/17. Now we'll go back to the original problem and record our answer. F of g of 4 is equal to 1/17. Now we'll look at another example where the function f of x is a direct variation linear function. It's a line that goes through the origin with a slope of 2. G of x also goes through the origin. It's a linear function, but a slope of 1/2. We want to find f of g of x and g of f of x. And according to the directions, we're trying to prove that these two expressions will both simplify down to x. We'll start with f of g of x. So we'll substitute, instead of g of x, we'll do 1/2 x. Now we'll take this 1/2 x, this is our input in my f function. And in fact, f of g of x does equal x. We'll do something similar with g of f of x. So that is g of 2x, which is 1/2 times 2x, which also simplifies down to x. So it turns out whenever two functions, f and g, whenever f of g of x or g of f of x equals x, this has a special significance. These functions are called inverse functions. We'll get into that more later. But now let's do an application function, an application problem. We have a function f of x, which equals 2x squared plus 5, and g of x equals 2x plus a. And we're asked to find the value of a so that the graph of f of g of x crosses the y-axis at 23. So think for a minute about what that means. It means it goes through the point 0, 23, right? So what I want to do is take my f of g of x, and I can say f of g of 0 then will equal 23. So let's look at f of g of 0. G of 0 is 2 times 0 plus a. G of 0 equals a, right? So f of g of 0 is equal to f of a. So now let's look at my f function and substitute a in place of x. I get 2a squared plus 5. And I know that this will equal 23. So I can solve for a here. Divide both sides by 2. Take the square root of both sides. I get a equals plus or minus 3.